Hello students, welcome to yet another session of mathematics, and today we'll be discussing on the topic of matrices and determinants. Please share the YouTube link to your friends and ask them to join immediately before it's too late, and those who have not subscribed to our channel, please subscribe it and get latest updates on live sessions and recorded videos of Brilliant Qatar. And let's go to the topic of matrices and determinants. Okay, so let's start away with the questions now. The first question: the number of possible matrices of order 3 by 3 with each entry 2 or 0. So I'm trying to make a matrix of order 3 by 3. So if it's a matrix of order 3 by 3, we definitely know that there are 9 elements in that matrix. There are 9 elements in that matrix, and every space in the matrix should be either filled by a 2 or a 0. Yes? Yes, right answer, Prapti. Already answers started coming. So it's like every space in the matrix should be filled by a 2 or a 0. So the answer is 2 raised to 9. It's a method of fundamental principle of counting where every box has 2 options for each of them. So 2 raised to 9, which is 512. And for easy remembering, you can learn it like a formula as well. The number of entries raised to number of elements in the matrix. Number of elements in the matrix. So this is a 3 by 3 ordered matrix. Hence the number of elements is 9 and the number of entries that are allowed is 2. So 2 raised to 9. If there are 3 elements and the order is 2 by 2, it would be like 3 entries. An order is 2 by 2 means 4 elements in the matrix. The answer is 3 raised to 4, which is 81 possible matrices. So my answer is option D right now, which is 512. This is for an example, okay? The question here was 2 raised to 9. Right answer Dhruvil, right answer Ebin and Kevin. Now let's move on to the next question. A is given to you and they say that A plus A dash, I believe everybody knows what is A dash. A dash refers to transpose. A dash refers to the transpose of a matrix. So A plus A dash, A plus A dash. So let's say what's A plus A dash? Cos alpha minus sin alpha, cos alpha is A, is added with A dash, which is cos alpha minus sin alpha. The transpose minus sin alpha and cos alpha is equal to I, which is the identity matrix 1001. Yes, so now we can take the answers here and we can take out, on adding these two will be eliminated, these two will be eliminated. We can see it's going to be cos alpha plus cos alpha, which is 2 cos alpha, equal to the right hand side 1. So cos alpha equal to 1 by 2 implies alpha is equal to pi by 3. Alpha is equal to pi by 3. Right answer, Prapti. So answer is option B, pi by 3. The angle which satisfies the matrix A so that A plus A dash is equal to I. Right answer coming from Hanan and Joel as well. Okay. So it's easy question. 1 mark again. This is a type of question which is the most anticipated question this year, or not every year, from matrices. They do like to ask a question based on finding the order of a matrix with respect to addition and multiplication and so on. Can you see there are almost 5 matrices given to you and they're saying the order of each of them. Yes, it's 2 by n, 3 by k, 2 by p, n by 3 and p by k. or the order of each of the 5 matrices. They're asking you what should be the restriction, means the conditions that these values n, k and p should follow so that py plus wy. Please tell me, if I'm supposed to multiply matrix P with matrix Y, I should be able to follow certain conditions, that matrix P is of order P by K. Matrix P is of order P by K and matrix Y is of order 3 by K. This product is defined only if these two values are same, that is k should be equal to 3, and after that the product matrix will be of order P by K. That is, the inside values represent equal values, but the outside values represents the order of the product. Likewise, let's see what's going to happen with wy. All of you, what is going to happen with wy? The matrix W has order. The matrix W has order n by 3. And we know the order of y, which is again 3 by k. Now you can try to do it. We know that these two are already equal, so nothing to know about that. And the outside will be the order of wy. What is the order of wy? N by k. Yes, answers started coming. Prapti, right answer. Joel, right answer. Okay, fine. So how do we take P by K and 3? It's given, my dear. It's given in the question itself that the order of these matrices are like this. Okay, X, Y, Z, W and P are matrices of order. It's given to you, so we just have to take it from that. Now, I'm going to add now Py plus Wy, where Py has order P by K and Wy has order N by K. Now we know that this is possible only if these two orders are equal, and that happens, that implies P by K order should be equal to N by K, implies P should be equal to N. P should be equal to N. So we got the understanding that P should be equal to N, then only we can add two matrices, and the product is only possible if K is equal to 3. From these two conditions, it's pretty obvious that option A is the right answer. Yes, Kevin right, Dhruvil right, Ebin also right. So we got the option that K is equal to 3 and P is equal to N. A question based on finding the order of a matrix is one of the most important questions you can expect this year. Not like this year, every year it's going to be the same thing that's been seeing in board exams. Based on order, multiplication and addition of matrices, they can ask a question. Please keep an idea on this. Okay, I hope everybody is clear with this. I'm moving on to the next question to make this concept more clear. Look at this. I'm saying that these two are equal matrices. Two matrices can be equal only if their corresponding elements are equal. So which two elements should be compared so that we can easily get values? Please compare these two. Please compare the last elements. Can I say 4x is equal to x plus 6 implies 3x equal to 6 implies x equals 2. The value of x is 2. Obviously option A is eliminated, option D is eliminated, but there are two options which has the value of x as 2. Let's go and find the value of y now. So easily here you can compare these two elements. I can say y is equal to 5x minus 7. Substitute the value of x, my dear students. Y is equal to 10 minus 7, which is equal to 3. So the value of y is 3 and the value of x is 2. So this is not an option. So my answer is option B. X is equal to 2, y equal to 3. Prapti, right answer. Kevin, right answer. Dhruvil, Yes, Sana, Abin. Yes, all of you are coming to right answers now. Start giving answers. Very easy topic, matrices, determinants. And we should make sure this topic is full mark for us. We cannot take a chance with matrices and determinants. It's expected 4 to 5 MCQs will be coming from this topic alone. Matrices, determinants unit will take away 4 to 5 MCQs. Okay. Now, next question. What is the order of matrix A? Order is M by N. Okay, and we have to find the order of matrix B such that both A, B dash and B dash A are defined. But you can see the answers are in terms of M and N. So we have to find the order of B also in terms of M and N. So let us assume first. Let B has order P by Q. Just assuming that the order of B is P by Q. So if A, B dash means transpose. So the transpose has order Q by P. The transpose has order Q by P. So they say that A, B dash is defined. So it's a product that's being defined. What's the order of A? And it's given to us as M by N. And the order of B dash is given to us as Q by P. Now let us see the conditions that should be necessary to make this product happen. We know that the most important condition is N should be Q. Yes. Similarly, let's go for the next product. B dash, which is again Q by P, multiplied with A, which is M by N. And they say that this order, this product is also possible or defined. Yes. So what's the answer again? P equal to M. So I got that N and Q are equal. I got that M and P are equal. Therefore, I had the order of B as P by Q. But we saw that P should be equal to M and Q should be equal to N. Then the order of B should be M by N. The order of B should be M by N. Right answer coming from Dhruvil, Prapti, Sana, Abin, Kevin, everybody given right answer. Very good. Very good, all of you. So again, see, a question based on finding the order of a particular matrix where the product is defined. In this case, the previous case, product and addition, both were defined. Yes, good. Good answers, all of you. Keep it up. So let's move on to question number 6. Yes, I want you to study few statements here along with this answer. Okay, it's about what happens to addition, subtraction, product of matrices if A and B are some matrices of some order or same order. So please remember, A plus A dash is always symmetric. Okay, A minus A dash is always skew-symmetric. Okay, and AB plus BA is always symmetric. AB minus BA is always skew-symmetric. I have given you now 4 of them. A plus A dash. Now remember, in all these cases, A and B are considered as square matrices. And this too happens if and only if A, B are symmetric matrices. This condition only places if A and B are symmetric matrices. The last two only satisfies if A and B are symmetric matrices. Then AB plus BA is symmetric and AB minus BA is skew-symmetric. Now the question also looks very similar to that. Yes or no? The question also looks very similar to that. So can you just cross-check with the question that AB dash minus BA dash is very similar to the fourth one? Yes, and in that case, can I say the answer is going to be skew-symmetric? Because being a square matrix, B dash is same as B and A dash is same as A. Both are having the same order, not talking about the elements. And they, A and B, are assumed to be symmetric matrices also, because this kind of questions normally comes when A and B are symmetric matrices. So listen once again, A and B are matrices of same order, then AB minus BA should be skew symmetric. So AB dash minus BA dash. Also, if they say AB dash plus BA dash, if they say AB dash plus BA dash, then definitely that is also going to be symmetric. Okay, so remember, AB dash minus BA dash is skew symmetric, but when it comes to AB plus BA and AB minus BA, they are symmetric and skew symmetric if and only if A comma B are symmetric matrices. A comma B are symmetric matrices. Okay, moving forward, my dear students, next question. Alpha, beta, gamma and minus alpha is matrix A. I am supposed to use the condition A squared equal to I. A squared equal to I. So the matrix is alpha, beta, gamma minus alpha multiplied with alpha, beta, gamma minus alpha equal to I 1 0 0 1. I believe everybody knows how to multiply. Yes, multiply the first row with the first column. You will get alpha squared plus beta gamma. Okay, I'm not interested in the other elements. Okay, I'm not interested in the other elements. Whatever be the situation in the other cases, it should be equal to this, and the condition should, because there is no option which says none of these. There is no option which says none of these, so one of these conditions should be true, and I can get the condition from the first product itself. Okay, because it's the same alpha, beta, gamma used everywhere. So from this, can I say that alpha squared plus beta gamma equal to 1? Now I have to rearrange this in such a way that one of the conditions comes true. I can see it's very closely related to C. Right answer coming from Prapti. Very good. It's closely related to C. Take it to the other side, it becomes 1 minus alpha squared minus beta gamma equal to 0. 1 minus alpha squared minus beta gamma equal to 0. Option C. Easy answer. So please remember, I'm not interested in finding the other elements because there is no option which says none of these. Okay, so I can just find the first one, use that to say the final answer. Okay. Let me move on, my dear students. Okay, question number 8. 1, A, 0, 1 is A. Then what is A raised to N? Normally when it's seen like this, some schools have taught you to do questions based on principle of mathematical induction. Your idea will go to that. No need. It's an MCQ question, so you need not go to that. So what is going to be A squared? 1A 0 1 multiplied with 1A 0 1. Your answer, first row with the first column is 1. First row with the second column is A plus A, 2A. Second row with the first column is 0. Second row with the second column is again 1. So answer is 1, 2A, 0, 1. We may not be able to generalize anything from this. So I'm going to check with one more. What is going to be A cube? A squared into A. So 1, 2A, 0, 1 is multiplied with 1A, 0, 1. Do the same product. You will see the first element is 1. The second element is 3A. The third element is 0. Fourth element is back to 1. Can you see that something is being generalized here? If I keep going like this, I can definitely say A raised to N will look like 1, N, A, 0 and 1. 1, NA, 0, 1. A squared gives me 2A, A cube gives me 3A, then A raised to N will definitely give me NA. So my answer is option A, 1, NA, 0, 1. Right answer is coming from Prapti, Dhruvil, Kevin and Abin. Okay, so no need to use any mathematical induction. It will follow a general pattern and it will be a 2 by 2 matrix itself. Okay, just try to understand what is the pattern that's being followed on continuous multiplication of a matrix A to itself. Okay, and you get the pattern A raised to n is 1, Na, 0 and 1. Okay, yes, I hope everybody is clear. Going on to the next question, number 9. A is a square matrix which follows the condition that A squared is I. It's not always true, but in this question they're saying A squared is I. And they're asking you to evaluate A minus I cubed plus A plus I whole cubed minus 7A. And it's like A minus B the whole cube, which is A cube minus 3A squared B plus 3A B squared minus B cube. Add it with A plus B cubed, A cubed plus 3A squared B plus 3AB squared plus B cubed minus 7A. Minus 7A. Now, they said A squared is I, but before going to that, let me make a quick recap on some properties. If you multiply any matrix with I, you will get the matrix itself, and any power of I is still I itself. Please understand this. You might know it, but those who don't know, try to learn it now itself. Multiply any matrix with I, it's A itself, and I raised to n. The power of any identity matrix is the identity matrix itself. So what is going to be A cubed? A cubed is actually A squared into I. And A squared in the second case is I. So I into I squared is still I. A multiplied with I is still A. And I raised to 3 is still I. Again, A cube is A squared A. Then again, this is going to be 3. A squared is I into I is still I. 3A I squared is 3A. And I cube is still I minus 7A. Okay, we know A squared is also, again, once again, A squared is I. I into A is A minus 3I plus 3A minus I plus A plus 3I plus 3A plus I minus 7A. You can clearly see some of the terms are being cancelled off. Minus I plus I minus 3I plus 3I, and add all the A's. A plus 3A, 4A, 5A plus 3A, 8A, 8A minus 7A. The answer is A, option A. Yes, good answer coming, Prapti, Drivil, Hanan. Yes, Sana, Abin, all of you right answer. Good. So the answer for this is option number, question number 9, option A. So very common question for expanding a matrix expression, expanding a matrix equation. You are going to get something, some relation given to you in the question to be utilized maybe, or maybe not given also, but still you can come to an answer like this in the exam paper. Okay, fine. Moving on, question number 10. Question number 10 says, if the product of A and B, you multiply a matrix A with matrix B, the answer is a 0 matrix, then which of the following is correct? Most of you will go for option B. Option B, which says A is 0 or B is 0. If I have to multiply two matrices and get the answer as 0, isn't it necessary that one of them should be 0? No, it is not necessary that one of them should be 0. You can take an example like this. See, I will show an example where both the matrices are not 0, but still the answer is 0. Okay, look at this matrix B. Do you see that A is a non-zero matrix, B is a non-zero matrix? Right answer coming again from Sana, Abin, Kevin, Druvil. Good. Now, what happens if I multiply A with B? You can check yourself. You are going to get a 0 matrix. No doubt. But is A or B 0? Not 0. So you can say it is not necessary that What is the difference between it is necessary that either A is 0 or B is 0 and it is not necessary? Sometimes if A is 0, then the product is definitely 0. If B is 0, the product is definitely 0. So you cannot say that it will not become 0 if they are 0 in A and B. Fine. So the condition is very clear. It is not necessary. It is not necessary that either A or B should be 0. Okay, A is 0 or B is 0 is not a necessary condition, but if they are 0, the product is 0. But if they are not 0 also, the product can be 0. That is why option A is the correct answer. It is not necessary. Not necessary. Very good, all of you. Moving on. Question number 11. A matrix A is given to us as a 2 by 2 matrix. Understand the way of writing this. It means that it's a 2 by 2 matrix. 2 by 2 matrix means it's going to be A11, A12, A21, A22. We do have very silly questions like this in the textbook which says to create or construct a matrix of order 2 by 2 where they give you a relationship with I and J. You just have to use that relationship, construct the matrix and give it to them. For each element, you know what is I, you know what is J, substitute, get it over here and put it over there. Fine. But this is a different question. They say that Aij is 1 if I and J are not equal. So you can see that I and J are not equal in these two cases. Yes, 1 and 2 are not equal. I and J are not equal. Then in that case, those two elements are definitely 1. Those two elements are definitely 1. Now, can you look at the next case? If I and J are equal, if I and J are equal, the element is 0. Yes? So this is my matrix A. Now they're asking you what is A squared? I constructed the matrix A using the relation between I and J. Normally they will give you an equation, you just have to construct, that's all. But they are not satisfied with just constructing it, they're asking you to find what is A squared. A squared. Answers started coming. Very good. Kevin, Dhruvil, Prapti and Sana. Yes, very good. A squared is going to be 0, 1, 1, 0 multiplied with 0, 1, 1, 0. You will definitely see first row multiplied with first column, you will get 1. But the first row with second column will result in 0. Second row, first column will also result in 0. But second row, second column will again come back to 1. This clearly looks like an identity matrix. It clearly looks like an identity matrix. So my answer is option A. Identity matrix. So constructing the matrix and then finding out what is A squared. Constructing the matrix and then finding out what is A squared. Good answers, all of you. Yes, one or two got confused in that. Some of them give option C. Please be careful. It's not 0. It's I. Okay. And you've corrected it later. Good. Thank you. And so everybody, I hope the construction is very clear. Okay. Moving on. If matrix A is both symmetric and skew-symmetric, what is the meaning of being symmetric? Symmetric matrix is a square matrix where the diagonal of the matrix can be any elements, but the triangle above the diagonal should be exactly the same as the triangle below the diagonal. That's how a symmetric matrix looks like. But when it comes to a skew-symmetric matrix, so this is symmetric. This is symmetric. But when it comes to a skew-symmetric matrix, when it comes to a skew-symmetric matrix, the diagonal cannot be anything, but the diagonal should be all 0 elements. And the triangle above the diagonal should have an opposite sign with respect to the triangle below the diagonal. Now, it has to be both symmetric and skew-symmetric. Symmetric says diagonal can be anything. Skew-symmetric says diagonal should be 0. Then the only option is diagonal should be 0. So my diagonal should always be 0 if the matrix has to be both symmetric and skew-symmetric. And symmetric says the elements above the diagonal should be same as the elements below the diagonal. But skew says I should have an opposite sign. The only number in mathematics which is irrespective of a sign is 0. So now if you look at it, if you look at this, diagonal can be anything or 0, fine. If you put a minus sign for a 0, it's still 0 only. Minus sign is not going to affect the 0, right? So we know that all the elements is 0. It's going to be what? Both symmetric and skew-symmetric. So A is a 0 matrix. It's a very good question for 1 mark. Okay, right answer coming from Ebin, Sana, Dhruvil, Prapti, Hanan and Joel. So a matrix which is a 0 matrix is both symmetric and skew-symmetric. Question number 13. Now it's given to us that A is equal to Aij is M by N is a skew-symmetric matrix if Aij equal to 0 for I equal to j, right? For I equal to j, Aij is 0. That's a diagonal. This means that it's the diagonal. These two conditions says for a diagonal. And M is equal to N makes sure that it is a square matrix. Then if it has to be skew-symmetric, or if I not equal to j, Aij should be equal to minus Aji. The opposite sign should come in the lower triangle. The opposite sign should come in the lower triangle. Definitely the condition for what? Skew-symmetric. So skew-symmetric means the diagonal should give me zeros. That's given to us in the question. Then which other condition should be satisfied to make it skew-symmetric? I'm expecting a question like this year based on the definitions of special matrices that you've learned in chapter 3. You've learned about identity matrix, where it's again a matrix like this, but all the diagonal elements are 1. So Aij equal to 1 for I equal to j, and Aij equal to Aji equal to 0. All the other elements should be 0. That's an identity matrix. And when you come to a scalar matrix, Aij equal to any real number for I equal to j. The diagonal elements should be the same number. Okay, so these kind of questions are very important for us in this year's board exam. Try learning the definition of a matrix and try to compare that with the construction they're giving us like this. Okay, proper definition should be studied, otherwise you will not get these kind of questions. With respect to I and j, they can make you to do it. Okay, okay sir, fine. Let's move on. Come on, question number 14. Find the value of x if these two determinants are equal. Determinant of x to 18x equal to determinant of 6 to 18, 6. Determinant x squared minus 36 equal to 36 minus 36. That is x squared equal to 36. Implies x can be either a plus 6 or a minus 6. Option B. Simple question. Yes, it has come. It's a very simple question. Right answer coming from Hafez, Sana, Joel and Prapti. Good. Now, if x determinants are given to you as equal, find the value of x. A simple textbook question this is. Nothing creative. It's just a simple textbook question based on a 2 by 2 determinant. Moving on. There are two values for a which makes the determinant equal to 86. The question is about a determinant which has an unknown value called a. 1 minus 2, 5, 2a minus 1, 0, 4, 2. And they said that if you try to solve this determinant, you will definitely get two values for a. Everybody knows how to solve a 3 by 3 determinant. Come on, how to solve a 3 by 3 determinant? 1 multiplied with 2a plus 4. Yes, 1 in the first row and the minor of that element is over here, right? The minor of 1 is this. I'm using that to find the minor 2a plus 4. Then the next element is minus 2, that's minus of minus 2 multiplied with the minor of minus 2. That's going to be 2 2s are 4. And then 5 multiplied with its minor, it's going to be 8. equal to 86. Now we have to solve this. Yes, we have to solve this. Any other values missing? Just cross checking. This was 2a. This was 2a. I'm sorry. So this is going to be 2a squared. 2a squared plus 4. Sorry, it's 2a squared. Fine. Then my 2 multiplied with 4. Yes. 4a. 4a. Okay. And 5 multiplied with 8 is equal to 86. Come on. So let's try to solve it. This is going to be 2a squared plus 4 plus 8a plus 40 equal to 86. Solving this, we get 2a squared plus 8a is equal to 44. Goes to the other side, it becomes 42. So it's a quadratic equation now. A squared plus 4a minus 21 equal to 0. You have to factorize this quadratic equation as a plus 7 and a minus 3. A plus 7 and a minus 3. Yes? Okay, fine. Equal to 80. A plus 7 and a minus 3. So the answers for the values of a is minus 7 and 3. The sum of these numbers. The sum of these numbers. So minus 7 plus 3 is negative 4. Negative 4 is my answer. Negative 4, option C. Negative 4. Yes, good answers. Prapti, Hafiz, Sana, Drivil, Kate and Kevin. Good answers all of you. So we got the answer as option C, minus 4. The two values of A added. Question number 16. Which of the following is correct? What is the definition of a determinant? Not the numerical definition. The numerical definition says is the sum of the product of elements of any row or any column with its corresponding cofactors. What is the definition? The sum of the product of an element of any row or any column with its corresponding cofactors. But the statement definition is determinant is a number associated to a square matrix. A matrix which is not a square matrix cannot have a determinant. So determinant is always a number. It's a number. It's not a square matrix. Many of you tick option A, but determinant is not a square matrix. It's a number or a value obtained from a square matrix. Good answer. Again coming from, yes, all of you right. Everybody is giving the right answer. Good. It's good you know the definition. It's a very common question nowadays. Determinant is a number associated to a square matrix. Question number 17. Now this from questions onwards, we have few properties based on determinants. So I've already prepared the properties for you. If those who have not learned it, please go through it now itself. Others, please, if you know it, you can just start answering question number 17. The first one says, determinant of a matrix is same as the determinant of its transpose. Even if you take the transpose determinant will be same as the matrix determinant. Determinant of the inverse of a matrix is 1 by the determinant A. 1 by the determinant A. Right answer coming from already from Prapti and Abin. Okay. Then determinant of K into A. K is a scalar number. Remember, K is a scalar number. Then the answer is K raised to n, where n is taken from the order of the square matrix. K raised to n, determinant of A. What is determinant of A into B? Don't multiply AB. It's simply determinant of A multiplied with determinant of B. Determinant of adjoint A. Determinant of adjoint of A is determinant of A raised to n minus 1. If somebody asks you to find. So these are all properties. Now you can see that I'm taking the adjoint twice. When I'm taking the adjoint 2 times, the power of n minus 1 will become 2. And if they ask you a question where you're taking the adjoint 3 times, the power of n minus 1 will become 3. The power of n minus 1 depends on how many times you're taking adjoint. How many times you're taking adjoint. And there is a 5-star property. For me, it's a 5-star property. Because it's always a confusing question. This will come for 1 mark. You might think, what is this question doing for 1 mark? How can I multiply a matrix with its adjoint? Finding the adjoint is a very long process. Many of you forget that there's a property existing for that. If you multiply any matrix with its adjoint, the answer is always the determinant of A multiplied to its identity. Identity is 1 0 1 0 1, like that. So that determinant gets multiplied. Say for example, the determinant of A is k, and the identity matrix is going to be multiplied with k, and 1 0 0 1 multiplied with k will give me k 0 0 k. Very easy answer. Very easy answer. It's a very important property for us. Now let's going by the question now. The question says determinant of A inverse inverse. Beautiful. Many of you have given the right answers. What is the determinant of A inverse inverse? Double inverse. So determinant of A, if this is a matrix, inverse is going to be 1 by determinant of that. But that's inverse of A itself. So again reciprocal happens. The answer is determinant of A. And what is the determinant of this matrix A? 8 minus 3, which is 11. Answer is option B. Very simple question. Determinant of A inverse inverse. It's again back to what? Determinant of A. Double inverse. So let's go back to the same determinant A. Right answer, all of you. Moving forward with the property based questions. One question from this property is like 95% chance of coming. One question from one of these properties. A and B are square matrices of order 3. A is having a determinant 5, B is having a determinant 3. Then find the determinant of 3AB. Can you see that 3 is a scalar number? 3 is a scalar number. According to the previous properties, a scalar number, property number 3 says, will come out with the power of n taken from the order. We know that the order is a 3 by 3 matrix. So this is going to be coming out of the determinant with the power of 3. And the product of AB will be determinant A multiplied with determinant B. 3 raised to 3, 27. Determinant A, 5. Determinant B, 3. Multiply, answer 405. Option A. 405. Option A. Simple question based on multiplying a number with the product of two matrices. Option A. Got it? Anyone having a doubt in this? Okay, moving on. Given a square matrix A of order 3 by 3 and the determinant of that matrix is 12, find the value of determinant A into adjoint A. Determinant of A multiplied with adjoint A. Do you see that it's a product of two matrices? Adjoint is also a matrix. According to our understanding, product can be split as two different determinants. And we already know the determinant of adjoint A is determinant of A raised to n minus 1. If I combine these two, the bases are the same. You can add the powers. You can learn it like a formula itself. This you can study as a formula itself. That determinant of A into adjoint A. Determinant of A into adjoint A is determinant of A raised to n. And here determinant of A is 12. And the order is a 3 by 3 matrix. 12 raised to 3, which is 144 into 12. So the answer is 1, 7, 2, 8. Option A. Option A. Right answer Tushar. Right answer Hafiz. Right answer Abin. Right answer Prapti and Drivil. Very good. So the answer is 1728. 1728. Okay. Moving on to the next question. A is given to you as a matrix. They're not this time, they're not giving you the determinant. You are supposed to find the determinant. Then the value of determinant of adjoint A. First, let me write the determinant given to me. What's the determinant of A? 1, 0, 0, 1, 1, 2, 3, minus 1, 9. Now, before going to the answer, on seeing this question, I'm just being reminded with some very, very common property. Okay? Keep this in mind. It might be helpful for you. by chance, if I have a determinant, okay, if I have a determinant where the upper triangle means anything above the diagonal is completely 0, or maybe even the lower triangle, which is everything below the diagonal, is completely 0, or maybe even both upper and lower triangle are completely 0. Remember, either only the upper triangle is completely 0, or second case, only the lower triangle is completely 0, or third case, both upper triangle and lower triangle are completely 0, then we can simply say the determinant is the product of the diagonal. Very simple. Don't waste your time to find the determinant. Simply multiply diagonal elements. 6 5s are 30. But this question is not possible because this guy is not 0. If I draw a diagonal like this, that guy is not 0. That's why in this question it's not possible, but that case it's possible. Okay, so I'm talking about this question now. Can you help me find the determinant? It's going to be 1. Other two elements in the first row are 0, so forget about it. 9 plus 2, answer is 11. So determinant of A is 11. Now they want the determinant of adjoint. Adjoint. How many times adjoint? 2 times, right? So the answer is going to be determinant of A raised to n minus 1 squared. Why squared? Adjoint is taken 2 times. Adjoint is taken 2 times. So the answer is 11 raised to n minus 1. The order is a 3 by 3 matrix. So n minus 1 is 3 minus 1, which is 2. So it's actually 11 raised to 4. 3 minus 1 is 2, squared is 4. 11 raised to 4, and 11 raised to 4 is 14641. Option D, 14641. So please keep this idea also in mind. Please keep this idea also in mind. Okay, fine. Correct answers coming from Prapti, Dhruvil, Hafiz, Sana and Ala. Good. Okay, fine. I believe everybody is clear with this, right? Double times. If triple times adjoint, n minus 1 cubed. Okay, can come for a 2 by 2 matrix. Triple times adjoint. Next question, 21, a very interesting question based on the properties. So many properties are going to be applied simultaneously here. I would like to go for the second condition. It says determinant of AB inverse is 8, which is product determinant A and determinant of B inverse is 1 by determinant B equal to 8. So can I say determinant A is equal to 8 into determinant B? Yes. Now go for the first one. First one says determinant of A, B, A transpose is equal to 8. It's not A inverse, it's A transpose, remember. So it's going to be determinant A into determinant B into determinant A transpose, which is same as determinant A. Property number 1 says determinant of A transpose is same as determinant A. That is also equal to 8. Substitute 8 into determinant B into determinant B into 8 into determinant B equal to 8. Can I take out? Yes. Now I get the answer that determinant B cubed is equal to 1 by 8. So determinant of B is 1 by 2. So what is the determinant of B? 1 by 2. If determinant of B is 1 by 2, then what is the determinant of A? 8 into 1 by 2, which is equal to 4. Determinant of A is 4. Determinant of B is 1 by 2. Yes? Right answer, Tushar. Tushar gave me the right answer already. Then what is the determinant of B, A inverse, B dash? Determinant B, 1 by determinant A, determinant B. determinant B is 1 by 2 into determinant A is 1 by 4 and again determinant B is 1 by 2. Yes, answer 1 by 16. Answer is 1 by 16. Option C. Option C, 1 by 16. Yes, right answer coming from Kevin, and half is also. Answer is 1 by 16. Yes, I have done few steps here. I agree. Is it an MCQ question for 1 mark? I would say yes. If they want to make the level a little bit higher, I just used almost every property we have in determinants other than adjoint. Yes, so please learn these questions. It's good. It's a good question, okay? A is a singular matrix. Then what is A into adjoint A? What is A into adjoint A? The last 5-star property I said, A into adjoint A is determinant of A into I. Yes? If I say determinant of A is some number called K, multiply to the identity matrix I, and it is going to look like K 0 0 0 K 0 0 0 K. It's a matrix where all the diagonal elements are the same. If such a situation comes, it's the definition of a scalar matrix. Is the definition of what? A scalar matrix. So A into adjoint of A is always what? A into adjoint of A is always a scalar matrix. Good question. Keep in mind. Okay. Moving on. Question number 23. They are saying that f of x is a determinant like this. Then find f dash of 5. You should be knowing what f dash means. It is the derivative. Yes. A question of derivative comes in determinants. Derivative of f of x. So let's find out what is f of x first. Yes, I'm going to solve it using determinants. X multiplied with 1 plus 2x. 4 multiplied with 1 plus 4. And 5 multiplied with x minus 2. This is f of x. Multiply x plus 2x squared plus 5 fours are 20 plus 5x minus 10. 2x squared plus 6x plus 10. Now what's f dash? What's the derivative of this function? It is 4x. It's a simple derivative. That's why I'm doing it fast. What's derivative of 2x squared? 4x. And what's derivative of 6x? 6. And I'm supposed to find what is f dash of 5. 4 into 5 plus 6. Answer is 26. Option B. Answer 26. Yes, Jason, Prapti, Sana, Hafiz, Kevin. Very good. Your answer is 26. Clear answer. Okay? Correct. So let's move on. Question number 24. Find the adjoint of a 2 by 2 matrix. The matrix A is given to you. It's a 2 by 2 matrix which says P, Q, R, S. Remember all of you, expecting a question for a 2 by 2 matrix whose adjoint is necessary. What's the technique or easy shortcut to find the adjoint of a 2 by 2 matrix? You have to interchange the elements along this diagonal. Interchange elements. It's only for a 2 by 2, okay? Not for every matrix, not 3 by 3. It's only for a 2 by 2 matrix. It works. Interchange the elements in the main diagonal. Now consider this diagonal RQ. Here you have to change the sign. Don't interchange, only change the sign present. Then what is going to be the adjoint of A? If you interchange the elements, it's going to be S here, P here, and if you change the sign, it's minus R and minus Q. The only option which satisfies our answer, S minus Q minus RP. S minus Q minus RP. Option A. 24, option A. Beautiful. Already answers coming very well. Good. Good, all of you. So A is S minus Q minus R and P. Moving forward. Question number 25. If B is multiplied with a matrix, B is multiplied with the matrix 1, minus 2, 1, 4. And the result is another matrix which is 6, 0, 0, 6. And straight away I am writing that as 6i. Don't mind. 6 comes out. It's a matrix which looks like 6i. I am supposed to find B. If I can take this over to the other side, B will be coming, right? 6i is multiplied with 1 minus 2, 1, 4. Don't forget it's going to the other side, or it's like being inverted. The inverse of that matrix. What is the formula to find the inverse of a matrix? What is the formula to find the inverse of a matrix? Adjoint by the determinant. And it's definitely a 2 by 2 matrix, right? Yes? Understood? It's definitely a 2 by 2 matrix. Can we find the inverse of a 2 by 2 matrix fast, please? 6 multiplied with I multiplies with anything is the same thing. Can you find the adjoint? Interchange the elements in the first diagonal, change the sign in the second diagonal, divided by the determinant of this matrix. 4 plus 2, which is 6, no doubt. I can say 6 and 6 will cancel. So my final answer for this question is simply the matrix 4, 2, minus 1, 1. 4, 2, minus 1, 1. Which option? Option B. Option B. 4, 2, minus 1, 1. Okay? Easy answer. Yes, answer coming from Hafiz, Prapti. Yes, good answers. Fine. Moving on to the next question. Yes, this is a type of question, again very important. A system of equations. You are expecting 5-mark question from this category to solve the system of equations, right? But there are certain conditions which follow this. The condition is if it does not have a unique solution and if it has a unique solution. If the system has unique solution, then the determinant corresponding to the matrix should be not equal to 0. If the system should have a unique solution, the only necessary condition is the determinant not equal to 0. If it does not have unique solution, then in that case it could be either infinite solutions or no solution. Infinite solution if adjoint of A into B is a 0 matrix, and no solution if adjoint of A into B not equal to 0. You can remember this condition. If a question based on infinite solution and no solution comes, definitely going to be the condition of this equation. Adjoint of A into B is 0, adjoint of A into B not equal to 0. But if it's a question of unique solution and no unique solution, it's definitely going to be based on only this, the determinant. The determinant is 0. The determinant is 0. So let's try to find the determinant here. Determinant of the first is going to be lambda minus 3 and 1. Second equation 1 lambda 3. Third equation 3 1 5. You try to say that this determinant is 0 because it does not have a unique solution. Solve it. Lambda into 5 lambda minus 3 plus 3 into 5 minus 9 plus 1 into 1 minus 3 lambda equal to 0. It's going to be 5 lambda squared minus 3 lambda minus 5 minus 9 is minus 4 into 3 is minus 12, and then plus 1 minus 3 lambda equal to 0. So the equation is 5 lambda squared minus 6 lambda minus 11 equal to 0. You have to solve this quadratic equation. On factorizing it, it's going to be 5 lambda, product is going to be minus 55, sum is going to be minus 6, so it's going to be minus 11 and plus 5. So the factored form is 5 lambda minus 11 and lambda plus 1 equal to 0. So what are the values of lambda? So the values of lambda is equal to 11 by 5 or minus 1. 11 by 5 or minus 1. So the answer is 11 by 5 or minus 1, which is option A. Yes? Option A. So a question based on this is also expected. This is the last topic in determinants. The last topic in determinants. So a question based on this is also expected. And I think I've been able to cover almost every idea and concept in matrices and determinants. And I would like to stop today's session in this question. I hope everybody has cleared your doubts with these concepts. Please make sure you study this topic very well, because you need this for at least 4 to 5 MCQs in this year's board exam for this topic of matrices and determinants. So I'm signing off now, and I hope to see you soon with another topic. And thank you, all of you. Have a very, very nice day.
Brilliant Qatar, your trusted coaching partner for IIT, JEE, NEET, Science and Commerce tuitions with 10 years of excellence in quality training. Brilliant Qatar.